Today we're going to talk about scatter plots and regression lines. It's going to be very intensely calculator driven, so make sure you got your calculator with you, and if you haven't gotten that TI calculator yet, now's the time because you won't be able to do this unless you've got one of those graphing calculators. So anyways, we talk about scatter plots. You've probably seen these before. They're just a set of points that are graphed from data given in two variables. We call that specifically something called bivariate data. All right, in other words, two variables creating some data, and scatter plots are basically going to show relationships between those two variables. All right, now in each case I have here, I have a situation where these data points form a pattern. So if the pattern rises as I go from left to right, we say that's a positive sloping set of data or a positive correlation. If the data falls as I go from left to right, then we say that data is a negative correlation. And if it's just scattered all over the place, we say this data has no correlation. So if I look at these two examples and I ask, do these graphs have positive, negative, or no correlation, we can see that this graph tends to rise as I go from left to right, so this would have a positive correlation. All right, whereas this graph is scattered all over the place, so this has no correlation. Now today, once again, we're going to take and give you a lot of new definitions, so kind of be aware of that, and the calculations will involve lots of calculator use. Now, typically when we look at scatter plots, we can describe the patterns by linear equations or equations of lines, and we call those lines best fit lines. Some people will call them trend lines, and what it is, it's a straight line that represents basically the data on your scatter plot. And if you draw a best fit line, typically that line will go through as many points as possible, with some being above the line and some being below the line, as you can see in this set of data right here. Now, our calculators can calculate these lines very accurately and place these lines in such a way that the distance will be minimized from point to point from the line, and it will also calculate an equation of a line that gives us the best correlation. Now, these calculators will also calculate something called a correlation coefficient. And what that correlation coefficient is it's given by the variable r. And that variable is calculated as a number between 1 and -1. Any positive correlation coefficient, we'll talk about a positive sloping line. As you can see in the pictures below, there's a positive R value of 0.7 going up, positive R value of 0.3, and you'll see here that the R value is 0, which means my data is scattered all over the place and it doesn't really have any kind of a slope associated with it. Now if I look at the other correlations, we notice negative R values, and you notice the data seems to slope down. Once again, an R value of 0 represents a scattered all over the place set of data. As your R value gets closer and closer to 1, that means your data points will be looking more and more like a line, whereas as your data points are more spread out, your R value gets further away from 1 or closer to 0. One of the regression lines that we use, or one of the best fit lines that we use, is something called a least squares regression line. And what that does is it takes the sum of the squares of all the data points relative to a line and minimizes these distances here. So you can see that distance from this point to the line here is one number, the distance from this point to the line here is another, so on and so forth. What the calculator will actually do is it'll take all these distances and try to minimize those distances based on the calculation of the line that it gives. We do a couple of things with this data once we get it. We can do extrapolations and interpolations. An extrapolation is estimating values that will happen based on the data already given to us, and when we estimate those values, it will be of numbers outside the data region that we've been given. When we talk about interpolation, again, we're estimating values, but the values we're estimating for are values given within the data given. So if we were going to extrapolate, we're talking about values out here. Whereas if we're talking about interpolation, we're talking about values in here. All right? Let's give you a little taste of that right here. So once again, if we ask, based on the regression line that we have in this picture, what would be the y value if the x value were equal to 7? Well, here's an x value of 7. Now you'll notice there is no line here. But if we were to extend that line as such and find out where it intersected this 7, we would be extrapolating data and drawing across roughly. We could see that we get roughly a y value of 16 if x were equal to 7, and that's based on the line that's calculated. So this is in a case of extrapolation. Now, if we want to find the y value when my x value is equal to 3.5, that's data already within the given region graphed and calculated from the points given to us. So now, let's look at 3.5 and see how high this would go on the line. Move over and say, well, what would be my estimated y value? Well, in this case, y would equal roughly about 8. And this is interpolation. So it's finding y values within the values already given to us from a line calculated. All right, so now we've given you all the definitions. We're going to actually take and do some calculation. So here we go. First of all, I have a set of data. It talks about botulism cases over a set of years. And what we can do is we can actually manually go ahead and graph a scatter plot based on this information. So at 2001, we have roughly 36. At 2002, about 38. Around here. At 2003, about 20. Here, at 2004, 16. Let's say that's right around here. And at 2005, we have about 18. So that's going to be somewhere around here. And what we're going to do is we're going to take and draw a best fit line through that and then find its equation. Once we found its equation, we're going to do an extrapolation and find out the number of botulism cases we would expect from this given data in 2008. Now, as you can see, this appears to be moving down. So if I were to draw a trend line or a regression line by hand, I could estimate it to be somewhere around here. Writing the equation for that would be kind of a pain and not very accurate, so we're going to let our calculator do it. But we expect this data to have a negative correlation, and we expect it to be averagely linear because that looks somewhat like a line. But we'll find that out as we go through our calculator example. So why don't you get those calculators out and let's turn them on and let's start plugging in some data. So what I need you to do is the first thing we will do is hit this button right here that says Stat. And then we're going to go ahead and edit. So in this list right here, L1, we're going to type in all the years that we have. So why don't you go ahead and do that. Now that you've done that, what we'll need to do is get over to this list too. So we just hit our right arrow and it'll go over, and we type in all those sets of data in the Y column. And once you finish, your table should look something like this with all your years in your Y1 and all your cases of botulism in Y2. And what we're going to do is we're going to get out of this screen right now. So you're going to hit the second button, and right above this mode it says quit. So you'll do that to go back to your regular screen. The next thing we're going to do is we're going to try to graph this. And in order to do that, we have to turn what's called our stat plot on. So we're going to hit second, followed by Y equals, and you'll notice this screen comes up where it says stat plot. Where it highlights the number 1, we're going to press number 1, and you'll see most of your stat plots are probably turned off. We're going to go and make our little blinky, hit on the word on, and click enter, and you'll notice it goes from off to on. And then you'll also notice that your X's are going to be in L1 and your Y's are going to be in L2. And this is exactly what we want. So we're going to quit once again. Finally, we're going to take and graph this on our calculator. But if we were to hit graph right now, most likely you won't see anything. And what we have to do is we have to adjust our window so that we can see the data we've graphed. If I hit the button window, you'll notice that my X's are going from -10 to 10 and my Y's are going from -10 to 10 as well. But that's not what our data is doing. So what we're going to do is we're going to graph from the year 2000. So I'm going to set my X min at 2000. This you're going to have to learn to do on your own and figure out what numbers best give an example of the data you're trying to see. So I'm going to go from 2000 to 2010, and then my Y values, I'm going to go down and say, well, if I went from 0 to 50, I could probably see everything I need to. And once I've done that, I hit graph, and you'll notice, well, here's my data. It appears to be going down as it did in our previous example. And also what's happening is we can calculate a correlation coefficient from that, but we're going to need to do some things first. So I'm going to quit this once again. And next, I'm going to open up something called catalog. So if you can see down here, it says catalog. So I'm going to hit second and the 0 button, which goes to my catalog. And what I'm going to do is I'm going to cursor down so you can see I'm pressing the down button. And I'm going to do it until I get into my D's. So we keep going down until we find a word that says diagnostics. And right here where it says diagnostics on, you're going to click enter. And diagnostics on will come up on your screen and you'll hit enter again. And it'll say done. So we turned on our diagnostics. The next thing we'll do is we'll take and say, all right, let's go to stat again. And we'll move over. If you can see right here, it says calculate. So we'll move over and calculate. And what we're going to calculate is what's called a linear regression, or an equation for a line. So I'm going to hit the number 4, or I can cursor down to 4 and hit enter. Doesn't matter. And this will come up on my screen, and all I have to do is hit enter again. And what it'll do is it'll calculate the equation of a line in slope-intercept form. Notice I have a y equals ax plus b, or mx plus b. And I can write that equation right over here, which I'll do. And that's y equals negative 5.4 that's x. Let's go back to our calculator again. Plus about 10,840. So plus 10,840, roughly, is going to be the equation of my line. All right, given those x's and those y's. Okay? Now, if that's the case, I want my calculator to go ahead and graph that. So once again, I'll go back to this screen, and I'll also notice that in this case, I have this calculated R value. It's negative, which we expect it to be, and it's about 0.9. Let's just write that in right over here. So we've got an R value of negative 0.9, roughly. R equals negative 0.9, which means that this data is fairly linear, right? And not only is this data linear, but it's pretty close to 1, and it's negatively sloped, which is what we would expect. So the next thing we're going to do is we're going to take and graph this line on our calculator. Now, in order to do that, what we have to do is we have to go to y equals. So we go to y equals on our calculator, and if you have anything in here, just delete it or clear it, whatever you want to do. But in order to put the equation that we just calculated into this spot right here, we hit the following buttons. We hit bars, which is right here, followed by statistics. So we can move down to number 5, or we could just hit number 5, hit enter. And you'll notice over here is equation. What we're going to do is move our cursor over 2 times, and we notice that number 1 is a regression equation, and we're going to type that in here. And we notice that in this regression equation, we now have the equation that was calculated for us. So if I hit and graph that now, there's the equation of our line. And it goes through most of the points, some above, some below, and at their minimum distance. The calculator did all that calculating for us. So what we've done is we've calculated and drawn the best fit line. Now the next part of our problem was to predict the number of botulism cases that are going to exist in 2008. In order to do this on our calculator, what we would need to do is the following. We go to our table by hitting second table, and here's our calculator. Values of x's and y's. Now unfortunately, our x value is up at 2008. We'd have to go down forever in order to get there. It would take us a long time. There's another way to do this more efficiently. We hit second table set. You'll notice that our table here starts at 5. We could make that table start at 2000 if we wanted to, but a better way yet is to move our cursor down to where it says independent variables, talk about our x variables, and move that over to ask. So I'm going to do that and hit enter. Next, I'll go back to my table, and you'll notice something's happened. There's nothing in my table because it's waiting for me to ask the calculator a question. What do you want your x value to be? We want it to be 2008. And when I plug that in, I find out in 2008, based on the data that we have a negative case of botulism, which doesn't really make any sense, but what it says is botulism in 2008, based on our data, would basically go away. So once again, let's take a look at that number. I have negative 2.8, cases in 2008. Again, doesn't make a ton of sense because we know there's always going to be botulism, but this is how we go about figuring out an extrapolated case of data. You're probably going to have to go watch this again because it is kind of confusing. So here's another set of data, and it talks about contributions made to Republicans and Democrats over the given years, and we want to write a equation of a line that best fits the data, and we're going to predict the number of contributions in the year 2000. So we're going to go through the same thing we did in the last problem, a little bit quicker this time, but it'll give you some more practice on the calculator. So once again, turn your calculator on. Now the problem is we have data already stored in our calculator, so we're going to go through and get rid of the data we already have. So we go to y equals, and we're going to take that line out of there by hitting clear. And then we're going to go to stat, and we're going to hit edit. And we notice that in this case, we have all that previous data there. So what we're going to do is we're going to go ahead and clear that. If I go up to L2 and hit clear, and then go back down, notice the list 2 will be gone. And then move over to L1, hit clear, go back down, and that will be gone. So now I'm going to type in my years once again. Once you've typed in your years, move the cursor over to the next list and type in the amount of contributions. And now that we have all of our data typed in, we want to take and graph this. Now once again, let's make sure our window's set up appropriately for our graph. We need to see as low as 1990 in years and as high as 2006. So let's look at our window. And our window was set for our previous example. So what I'm going to do is I'm going to look at 1980 so I know that I'll see everything. And again, this is something you're going to have to figure out how to do. What's the best window to look at? And I'm going to go to 2010 once again so I see my whole range of data. But we also notice that our Y values are going to change this time. And instead of going up as high as 50, I'm going to need to see at least up as high as 1085. So I'm going to go from, we'll just go from 0 to, let's go 1200. And that way we'll be sure to see everything in that window. If I hit graph this time, here's our graph showing that our data is consistently going up. And what I can do now is I can calculate my regression line or my best fit line for this data. And we go through and do that the same way we did it last time. We'll hit stat, move over to calculate, linreg, which is number 4, and hit enter again. Now we notice we have the following equation for the line. We have y equals 49.7x minus 98,727. And we have an r value this time that is positive. We can see that here. All right. And it's pretty close to 1, so it says this data is going to be pretty linear. So let's go ahead and write that equation. We have y equals 49.7x plus, or I think it was minus actually. Let's go ahead and get rid of that. And it was minus negative 98727. Roughly right around here. That was the equation of the line. Now we're going to take and graph that on the calculator by going to y equals, hitting vars again. I'm going to hit the number 5 for statistics, move over to equation, hit regression equation, and then take a look at my graph. And there we have it. There's our best fit line, some of the points above, some of the points below, pretty close to the line. So my correlation is 0.9. It's not super spread out. And then we're going to take, and this time, we're going to do an interpolation because this problem asks us to predict the amount of contributions in 2000. 2000 we see is within the data given to us, so it's an interpolation. So let's go back to our calculator, go to our table, and that's already set up for us to ask about any number we want. Here's our value determined by our data at 2008. If we want 2000, I just hit 2000 and enter, and we see roughly we have 672.4, and that's, I believe, in millions of dollars in the year 2000. So we've gone through a couple examples of how to use that calculator to find regression lines, regression equations, how to graph those equations, how to do scatter plots, and how to find correlation coefficients. So you're going to have to practice that a little bit tonight, and we'll hit it again tomorrow.